Let's look at calculations involving pH and concentrations of acids and bases. And we'll talk about strong bases and strong acids because they completely dissociate in water. So given the concentration of the acid or the base, I'll show you how to calculate the pH or the pOH. We're also going to look at how to write the pH and concentrations with the proper number of significant digits. What are the pH and the pOH? Well, the pH tells us something about the concentration of the hydrogen ion in an acid or base, and the pOH tells us something about the concentration of the hydroxide ion in an acid or base. We can also use it for salts, but we're going to concentrate on the acid and the base itself now. So the definition of pH is the negative log, that's a base 10 log, of the hydrogen ion concentration. And the pOH is the negative log of the hydroxide ion concentration. You may recall that logarithms are just exponents. So we're looking for the exponent on 10 and the negative value of it. This is a diagram that we frequently use, and I strongly recommend. I learned it from Hubert Allier way back in the 1970s. This is his pH diagram. This is a logarithmic scale, and that's why the lines are straight. And you can see here the hydrogen ion concentrations are large here and small on the right. The hydroxide ion concentrations are large on the right and very small on the left. That's because the hydroxide ion times the hydrogen ion concentration, those two concentrations multiplied together are always equal to 10 to the negative 14th at our room temperature. And we see the pH here is 0 and the pH here is 14 on the right, and vice versa for the pOH. Thus, as the hydrogen ion concentration increases, the pH gets closer and closer to 0. And as the hydroxide ion concentration increases, the pOH gets closer and closer to 0. Let's look at this a couple of other ways. A high pH, then, is associated with a high hydroxide concentration, and a high pOH is associated with a high hydrogen ion concentration. A high pH here is associated with a low hydrogen ion concentration, and a high pOH is associated with a low hydroxide ion concentration. Because this is counterintuitive, we suggest you always draw this diagram whenever you're tested on pH or pOH or any acid-base calculation. Now let's practice pH and pOH using our definitions, which you'll see up on the right. So what is the pH of a strong acid with hydrogen ion concentration equal to 0.000457 molar? If you turn on your calculator, you'll press the negative key in parentheses. That's where it is on many keyboards. You punch in the hydrogen ion concentration. You don't need that 0 in front of the decimal point, so you type 0.000457. Watch those leading zeros carefully so you have the right number after the decimal point. Then you press the equal button and you get an answer, and that's the answer I got on my calculator. Well, surely there aren't 19 sig digs in this pH. Now we look and see that in the molarity of the hydrogen ion there's 1, 2, 3 sig digs. So the pH we get has to signal that there's 3 sig digs in the molarity. And we signal this with the number of digits after the decimal point. So we see 3 sig digs here, so there can only be 3 digits after the decimal point in the pH reading. And we do that. This is how we round it off. minus 3.340, of course, we change the sign on that and we get 3.340. pHs and pOHs are always positive numbers. Now, calculate the hydrogen ion concentration if the pH is equal to 4.25. This is the opposite relationship. Well, given the definition, we're going to have to raise 10 to the negative pH to find the hydrogen ion concentration. So remember, the pH is the exponent on 10, the negative value. So, here on this calculator, we press the blue second function button, and if we push the logarithm key after that, it's no longer log key, it's 10 to a power. Then we press the negative button down here, punch in the 4.25, push equal, and we get the answer that's shown here. And this is what messes people up. That e to the negative fifth means 10 to the negative fifth. Now we see 2 sig digs after the decimal point in the pH. And so how many sig digs are in the molarity? Clearly just 2. So the molarity here is 5.6 times 10 to the negative fifth molar. 2 sig digs in the answer is all. What about pOH and the hydroxide ion concentrations? Now remember, when we're looking with pOH and hydroxide, we're usually working with fairly high concentrations of hydroxide ions. So we're over here to the right of 7 pH, to the right of 7 pOH. So we're on the base side of the table. So you're going to punch the negative log, you're going to punch in the hydroxide concentration, and equal, and that'll give you your pOH. If the question asks for the pH rather than the pOH, you remember that the pH plus the pOH added together is always 14. So to find the pH from the pOH, you subtract your answer from 14. So let's try one. What's the pH of a 0.0032 molar potassium hydroxide solution? That's a strong base, so you're going to work from pH to pOH and then to the hydroxide. You're going to get the pH to the pOH. So the hydroxide ion concentration goes to the pOH, and from that you're going to get the pH. So go ahead and turn the video off and work this, and then check your answer. The pOH is going to be 2.49. So negative log of this 0.0032 is 2.49. Note, 2 digits after the decimal point. We then subtract that number from 14, and we get the pH, which is 11.50. Remember, the pOH is going to be 2.49 because this is a fairly high concentration of potassium hydroxide. So we're over here, and that's why the pH is going to be fairly high, certainly much larger than 7. Now, let's look at the opposite. If you're given the pH and asked for the hydroxide ion concentration, well, the first thing I would do is subtract the pH from 14 to find the pOH. It's a whole lot easier to work from the pOH to the hydroxide concentration. Then you just raise 10 to the negative pOH and find the right number of sig digs from the pH and pOH. Remember, it's the number of digits after the decimal point. So let's try one. Find the hydroxide ion concentration if the pH is 12.262. And notice, we've got here 3 digits past the decimal point in the pH. So turn the video off, and then you can come back and check your answer. The pOH will be 1.738, we subtract from 14, and 10 to the negative 1.738 is 0.0182 molar. That will be the hydroxide concentration. Of course, the pH now is very high, so we're over in this range. The pOH is going to be fairly low here in this range, and therefore a relatively robust hydroxide concentration makes sense. Now what do you do next? Well, you got to practice this. So get a worksheet and practice all of these skills. Best is to have a worksheet with questions on the front and the answers on the back, or someplace where they can hide.